If you build AI tools, you know the feeling. A user asks your chatbot a highly specific question, and it spits back a hallucinated answer or completely fails to retrieve the right data because it lacks the necessary background knowledge. The standard way developers solve this is with Retrieval Augmented Generation, or RAG. You take a massive corpus of documents and break it down into smaller text chunks so the AI can search them efficiently. But this slicing process strips away the surrounding context. This split screen shows exactly how that fails. A user asks for a specific company's performance, and the database finds a chunk saying revenue grew 3%. But without the company name or date attached directly to the text, the AI cannot verify the answer. By prepending document-level context to every chunk and adding a targeted re-ranking step, we reduce failed data retrievals by 67%. To set this architecture up, you will need three things: an Anthropic API key, an embedding model of your choice, and an existing knowledge base. Fixing retrieval right at the foundational chunk level is the necessary step to take an AI system from an unreliable prototype to a trustworthy enterprise tool. Step 1 is pre-processing. We start by loading your entire reference document into the Claude API cache just one time. Historically, generating context for thousands of individual chunks required passing the full reference document back to the model for every single chunk evaluation. Without a caching mechanism, that process is prohibitively expensive. This bar chart shows the impact of Anthropic's prompt caching on those processing costs. Because the system references the previously cached content, instead of reading the document from scratch every time, the cost drops to about $1.02 per million tokens. Eliminating that financial barrier turns an impossibly expensive theoretical process into a practical, production-ready solution. Now that the document is cached, we instruct Claude 3 Haiku to read it and generate 50 to 100 tokens of explanatory context for each individual chunk. You will pass in these exact prompt instructions. You can also customize this step by including a domain glossary if your documents use highly specific technical terminology. Next, we physically concatenate the text. We take that newly generated 50-token context and prepend it directly to the original raw chunk text. This flowchart tracks our next move. With our chunks now contextualized, we convert them into semantic embeddings and save them to a standard vector database. This handles our searches for broad meaning. At the same time, we send that exact same combined text into a parallel BM25 index. BM25 is a ranking function that relies on lexical matching to find precise words or phrase strings. Pairing contextually rich embeddings with a lexical index guarantees your system grasps both the general intent of a query and the exact technical terms inside it. With pre-processing complete, we move to runtime execution. When a user submits a query, we run it against both the vector database and the BM25 index simultaneously. If a user searches for error code TS999, the semantic vector database might miss the string because it is looking for broad error concepts, but the BM25 exact match path catches the specific identifier perfectly. We merge the results from both database paths and deduplicate them using RankFusion. This creates a preliminary list of the top 150 potentially relevant chunks. Passing 150 chunks to the generation model wastes compute and lowers accuracy. To fix this, we apply a dedicated re-ranking model, such as Cohere, to filter the list. This funnel illustrates the final filtration step. The re-ranker scores each chunk based on strict relevance to the original prompt, drops the noise, and passes only the top 20 chunks into the final LLM. Acting as a strict bouncer against irrelevant data, re-ranking protects the final generation model from distraction and hallucination. Your pipeline is now complete. The AI model receives the exact background knowledge it needs, directly resulting in highly accurate answers. To maximize your retrieval accuracy, follow this rapid-fire optimization checklist. First, always use hybrid search. Pair it with high-performing models like Voyage or Gemini. Prepend the AI-generated context, pass the hybrid results through a re-ranking step, and strictly limit the context window to the top 20 chunks. Finally, always run evaluations. You will need to test and adjust your chunk boundaries and prompt instructions based on the unique properties of your own documents. To deploy this yourself, check the link in the description for the Anthropic Cookbook, where you can copy and paste the actual implementation code. Adopting this specific, context-aware architecture ensures that your AI system operates as a highly reliable, productive